let z1 equal 1 plus I and z2 equal root 3 minus I. Part A, convert the complex numbers into polar form. Part B, evaluate 1 over z2, or the reciprocal of z2. Part C, evaluate z1 over z2. And part D, use your results from A and C to find the exact values of sine 5 pi by 12 and cos 5 pi by 12. Right, so we're certainly the last bit is not going to become very clear until we've done the rest, so let's begin. Convert the complex numbers into polar form. So part A, the first one we have 1 plus I. So nice little arc diagram. 1 plus I, so you've got 1 here and 1 here. Remember, that's the real axis and the imaginary. So 1 and 1 up there. You can see this argument here is pi by 4, and the modulus of z1 is the square root of the real part squared plus the imaginary part squared. So 1 plus 1 is 2, root 2. The argument of z1 is pi by 4, so that means z1 in polar form is root 2 cis pi by 4. Okay, can we squeeze z2 in there as well? Give it a go. Okay, so we've got a real axis and an imaginary one. And z2 is root 3 minus I. Right, so root 3 can be here. Minus I is probably, compared to the root 3, smaller, so maybe there, minus 1 on there. So it's over here. So you can see it's got a negative argument. If we just reflect, I find it easiest just to reflect back into what we know about. So if I can find this theta here. So that has a height of 1 and a width or an x-coordinate of 3. So that means tan theta equals 1 over root 3. And root left over root right, it's when it's 30 degrees, so pi by 6. So root 1 over root 3, 1 over root 3. So that means theta equals 30 degrees, which is pi by 6, which means the argument of z2 is going to be minus pi by 6. Remember, we're going here. So arg z2 equals minus pi by 6. Then we just need the modulus of z2, which is the square root of the 1 squared plus the root 3 squared. Okay, so 1 squared is 1, root 3 squared is 3, 1 plus 3 is 4, and the square root of 4 is 2, equals 2. So z1 equals root 2 cis pi by 4, and z2 equals 2 cis minus pi by 6. Okay, so that is part A dealt with. Part B, evaluate 1 over z2. So I'm just going to show you why this works, and then we'll think about it as a result you can just use. But if you just think of 1 in polar form, so if we just draw a really small diagram, well, 1 means 1 on the real axis. We have the real and the imaginary. 1 is just here, so 1 can be there. So it's 1 cis 0, so 1 equals 1 cis 0, right? So if I'm doing 1 over z2, so if we're dividing 1 by a general complex number, so if we just write it in general polar form, you might say 1 cis 0 divided by, so we modulus of z cis theta, something like that, right? So then if you think about the rules for multiplying complex numbers in polar form, you multiply the moduli and you add the arguments. For dividing, you divide the moduli and you subtract the arguments. So that ends up being 1 over the modulus of z times cis. Well, it's going to be 0 minus theta, so minus theta. So whenever you're finding the reciprocal of a complex number in polar form, so 1 over z is going to be 1 over the modulus of z cis minus theta. So then we could just use that So we are finding the reciprocal of Z2. So Z2 is 2 cis minus pi by 6. So 1 over Z2, well, it's going to be 1 over 2. So 1 over the modulus times cis. And then it's going to be minus theta. Well, theta was minus pi by 6, so minus theta will just be pi by 6. Okay, so that is the reciprocal of Z2. Part C, evaluate Z1 over Z2. So Z1 over Z2 equals, so we get the modulus of Z1, root 2. Modulus of Z2 is 2, so we divide those. It's root 2 over 2 times cis, and then we subtract the arguments. So it's pi by 4 minus pi by 6. So we're going to be adding. And just because I don't have a lot of space, I'm going to turn this pi by 4, well, I'm going to have a common denominator of 12. So pi by 4 can be 3 pi by 12. 3 pi by 12. And remember, it's minus pi by 6, or minus 2 pi by 12. So plus 2 pi by 12, like that. So that is going to be root 2 over 2, cis 5 pi by 12, like that. Part D, use the results from part A and C to find the exact values of sine 5 pi by 12 and cos 5 pi by 12, right? So if you think about this result from part C, this means that Z1 over Z2 gives you root 2 over 2 cos 5 pi by 12 plus I sine 5 pi by 12, right? That's what cis means. So basically, we know if we divide Z1 by Z2, then we get root 2 over 2 times cos pi by 5 pi by 12 plus root 2 over 2 times I sine 5 pi by 12. So if we do this division in Cartesian form as well, then we should be able to equate the real part and equate the imaginary part and deduce the values from there. So I'm going to do Z1 over Z2 in Cartesian form. So Z1 over Z2 also equals, well, Z1 was 1 plus I, and Z2 was root 3 minus I. So if we want to do this division in Cartesian form, we're going to multiply it by the conjugate of the denominator over itself. So root 3 plus I over root 3 plus I, okay? So that is going to be, well, 1 plus I, well, 1 plus I times root 3 plus I, where you've got 1 times root 3 is root 3. Then you've got I root 3 plus 1I, so that's root 3 plus 1I, plus root 3 plus 1I, plus, well, then you've got I squared, so minus 1 really. Minus 1, that's the I squared dealt with. On the bottom we have a difference of 2 squares, so it's root 3 squared minus I squared, right? So root 3 squared is 3, I squared is minus 1, so minus I squared is plus 1, so 3 plus 1 is 4. So that gives us root 3 minus 1 over 4 plus root 3 plus 1 over 4I. Like that. So I might put a bracket in all of that. Right? So all of that, remember that is Z1 over Z2. Okay, and now I'm going to set this equal to the Z1 over Z2 found in polar form. So that can be equal to root 2 over 2 cos 5 pi by 12 plus I sine 5 pi by 12, okay? So once you've got that, if we just get rid of this root 2 over 2, so if we just multiply through by, we're basically multiplying through by its reciprocal. So if we multiply through by 2, divide everything through by root 2, then we are going to have, so I'm going to multiply by root 2. So I'm going to multiply by 2 over root 2. So 2 over root 2, root 3 minus 1 over 4, plus root 3 plus 1 over 4 I, all of that equals cos 5 pi by 12 plus I sine 5 pi by 12, just like that. Okay, so I'm just going to now see if we can deal with this. The 2 is easy enough because you can just say, well, that 2 into that 4 is just going to leave a 2 on the bottom, and the same with that 4, so that's easy enough. For the root 2, I'm going to have to put it in the denominator for now, and then we might end up multiplying by it later. So that would say root 3 minus 1 over 2 root 2, root 3 minus 1 over 2 root 2, that's the real part on the left hand side, plus root 3 plus 1 over 2 root 2 over 2 root 2 I, so that's the left hand side, equals cos 5 pi by 12 plus I sine 5 pi by 12. I am going to rationalize this left hand side before we equate real and imaginary parts. So what we're going to do, we're going to multiply both of those fractions. So I'm going to take this fraction, I'm going to times it by root 2 over root 2 to rationalize. I'm going to do exactly the same with that fraction, times it by root 2 over root 2 to rationalize. So I'm going to say root 3 minus 1 times root 2 is going to be root 3 times root 2, which is root 6, minus 1 times root 2 is minus root 2, over, and then you've got 2 times root 2 times another root 2. So the root 2 times root 2 is 2, and 2 times 2 is 4. So root 6 minus root 2 over 4, plus, and we're on to the second term. Then you've got root 3 minus 1 times root 2, so that's just going to be root 6 plus root 2, plus root 2 over, and you've got exactly the same on the bottom, 2 root 2 times root 2 is just another 4, and that's I, and that equals cos 5 pi by 12 plus I sine 5 pi by 12. Okay, so now if you just compare the left hand side to the right hand side, you've got a real part plus an imaginary part equals a real part plus an imaginary part, right? So you can equate the real parts on the left hand side and the right hand side, and you can equate the imaginary parts on the left hand side and the right hand side. And if you consider the right hand side, well, the real part on the right hand side is cos 5 pi by 12. So cos 5 pi by 12 is the only real part of that right hand side, so it must be exactly equal to the real part on the left hand side, which is root 6 minus root 2 over 4. And exactly the same case for the imaginary part. You have root 6 plus root 2 over 4 I equals I sine 5 pi by 12. So sine 5 pi by 12 must equal root 6 plus root 2 over 4. So equating the real parts. Okay, so on the right hand side we have cos 5 pi by 12 equals, on the left hand side, root 6 minus root 2 over 4. Okay, so that is the first part of part D. That's what we were asked to do. And the second part, we need sine 5 pi by 12, so equating imaginary parts. Okay, on the right hand side we have sine 5 pi by 12, and on the right hand side root 6 plus root 2 over 4. So sine 5 pi by 12 must equal root 6 plus root 2 over 4. So that is a bit tricky, a bit time consuming, but it is quite a common application of complex numbers to do that, to find tricky cosine and sine of an angle. You can actually use it to prove compound angle identities as well.